Welcome to our mathematics class. In this lesson, we will focus on Introduction to Trigonometric Equations. We will look at three equations. Cos alpha is equals to 3 divided by 5. The second one, sin alpha is equals to 5 divided by 13. The third equation is tan alpha is equals to 12 divided by 5. Let us look at the first equation. We are given cos alpha is equals to 3 divided by 5, which means the adjacent side is 3 and the hypotenuse is 5. And in this case, we need to know the value of angle alpha. And in trigonometry, given these two sides, we can be in a position to determine the value of angle alpha. And now let us look into more detail on how can this be done. Now, we applied the cosine function to alpha, and it yielded to us the ratio 3/5. But now we want to undo the application of the cosine function on alpha, and now we apply another function to undo that, and that function is called the arc cos, which means now we're going to have the arc cos applied on cos alpha, and that will give us the arc cos on both sides. And now applying the arc cos on cos alpha yields to us angle alpha, and that will be equals to the arc cos of 3 divided by 5. And now this, we can find the value when we apply this on our calculator. And we say shift, then we press on the cos button to bring us the arc cos, which is shown in orange at the top there, and then we can put in the ratio for us, which is 3 divided by 5, and that yields to us an angle (53.1) degrees. Now we want to be sure that this angle 53.1 degrees is the correct angle of alpha. If we apply a cos on it again, will it give us the ratio 3 divided by 5? Now let's go back to our calculator and reset it, and now we want to see if we apply cos to 53.130 102.35, and there it gives us the ratio that we begin with, which is 3 divided by 5. Now, the more you practice this, the more it will make sense. But since you are new to it, we will need to be in a position to can do more than one example. Now let us focus on the second equation. In our second equation, we have sin alpha is equals to 5 divided by 13. Now let us look on how we can find alpha. Now this, in the same manner that we did for the cosine, we would apply the arcsine on the sine of alpha on both sides to be able to get alpha. So in this case, when we apply the arcsine on sine alpha, we will get alpha equals to the arcsine of 5 divided by 13. And now let us use the calculator to be in a position to find that. Sorry about that. Then we reset, and now we say shift to get the arcsine, and then we say we want to put our number. There's in a fractional form, that is 5 divided by 13, and then we close, and that gives us 22.619 degrees. So in this case now we can say our angle is 22.62 degrees. So if we punch this on the calculator, it should give us back the value that we were expecting, which is that the sine of alpha is 5 divided by 13. Now let us move to another equation in this to say here now we have a triangle that shows us that the opposite side is 12 and the adjacent side is 5, which corresponds to tan alpha is equals to 12 divided by 5. Now we need to move closer to solving this equation also. Now let's do that. Then, which means we can apply the arctan on tan alpha and on both sides, and then we can be in a position to get alpha. But in this case, you do not need to do the way I was doing it always. You can just write alpha equals to the arctan of 12 divided by 5, and then we can apply on the calculator to get the value of tan alpha. Sorry, of alpha. Now let's look at the calculator, and then we can reset and say second function tan to get arctan, and then we can put our ratio there, which is 12 divided by 5, and that yields to us 67.38. Now our angle is 67.38 degrees, and this is how we solve equation. So I look forward to seeing you in the next class when we will dwell much more deeper into these equations. And this is the start, and it will mean that you need to do more practice on this to be able to get them more clearly, and that they become part of you and they become your second nature. So remember that we are made perfect by practicing. May you have a good day, and we'll see you in the next class.